This video provides an introduction to the complex plane. Unlike real numbers, complex numbers cannot be ordered. One way to organize and illustrate them is by using a graph. To graph a complex number like 2 minus 3i, we modify our familiar coordinate system by calling the horizontal axis the real axis and the vertical axis the imaginary axis. Then complex numbers can be graphed in this complex plane. So looking at our illustration to the right, I've graphed the number 2 minus 3i. So we do it just like a normal, ordered pair. Right? We're going to go 2 in the real direction and then negative 3 in the imaginary direction. We get like this endpoint and we draw in our complex number. Each complex number, a plus bi, determines a unique position vector with initial point of the origin and a terminal point ab. This shows the close connection between vectors and complex numbers. Recall adding imaginary or complex numbers from like intermediate algebra. Right? If we wanted to add 3 plus 4i plus 4 plus I, we just added the real components together and the imaginary components together, and that gave us our answer. Graphically, the sum of two complex numbers is represented by the vector that is the resultant of the vectors corresponding to the two numbers. So let's find the sum of 2 plus 3i and negative 4 minus I graphically. We'll graph both complex numbers and their resultant. So starting with 2 plus 3i, we start from the origin. I'm going to go 2 in the real direction and then 3 in the positive imaginary direction. So I'm going to go to the right 2, up 3. There's my first complex number. Then negative 4 minus I. I'm going to go 4 in the negative real direction, so that's to the left. And then 1 in the negative imaginary direction, that'll be down. And there's my second complex number. Well, the sum is the resultant vector. To find the resultant vector, we're going to use parallelogram rule. To draw in your parallelogram properly, because we're actually on a coordinate system here, not before when we were doing vectors and we were just on blank white paper, here we have to be a little bit more careful. So when I go to put in my blue line up top, I'm noticing what happened when I drew my blue one in to begin with. From the origin, I went down 1 and to the left 4. So from the end point of my red one, I want to go down 1 and to the left 4. And that's where this will be as we're creating our parallelogram. And now I can just connect my two blues. There we go. The sum is going to be the resultant vector, which we know is the diagonal of this parallelogram. And nicely for us, we see the corner of that parallelogram is exactly at the point negative 2, 2. So our sum is going to be our resultant vector, which is negative 2 in the real direction, and then plus 2 in the imaginary direction, negative 2 plus 2i. And we certainly get the same answer if we do it this technique we did in beginning algebra. You may be thinking to yourself, well, why wouldn't I just do it that way? Because that was a lot easier than doing this parallelogram rule. And that's true, but a lot of times in math we learn different techniques to do the same thing because depending on what we're doing, depending on what the context is, one technique is going to be preferred over the other. But you can always check yourself with your beginning algebra technique.